Okay, moving on to question number 3 in experiment number 5, we see that we have limestone and concentrated sulfuric acid reacting. So we have our reactions, our reactants. We have calcium carbonate and we have concentrated sulfuric acid. So we know that the formula for sulfuric acid is H2SO4. Now, in terms of phases, if we look at our solubility rules, we see that carbonates, compounds containing carbonate, are generally insoluble unless when combined with group 1 metals or ammonium, which calcium is not. So we know that calcium carbonate is in the solid phase. Sulfuric acid, again, we remember that acids need water in order to be considered an acid, so we know that this has an aqueous phase. So we have our reactants, and we need to predict what our products are going to be. And just like what we saw for for question number 1 and number 2, we're going to be able to crisscross what we see here. Okay, so if we take a look at these, we have calcium, we have hydrogen, we have carbonate, and we have sulfate. So we can actually go through and we can crisscross these. Again, just like what we did for question number 1 and question number 2. So if we take cation number 1, so cation number 1, and cross it with anion number 2, we're going to have calcium and sulfate. Now again, one of the good things that might help you is to go through and identify what the charges are for each species in the original material. So we know that carbonate, polyatomic ion, has a -2 charge, and therefore for the overall charge to be equal to 0, we know calcium has to be a +2. We know that sulfate has a -2 charge because it too is a polyatomic ion. And in order for the overall charge to be equal to 0, we know that each of these 2 hydrogens have to have a +1 charge. So we went through, we determined what the charge are, now we're going to crisscross them. So we have calcium, 2+, and we have sulfate, 2-. And again, we want to make sure that our formula is balanced, so we take only our number, and we do another crisscross to where these are now the new subscripts of our formula. So we have Ca2, SO4, and there are 2 of them. Now, one of the other things when balancing chemical formulas that you've already learned is that you want the lowest denomination of subscripts. So with this, we can actually divide out both of these by 2. So we end up with calcium 1 and sulfate 1. And again, we know that when we have 1 as a subscript, that we omit it because it is understood to be there. So our product, calcium sulfate. Now, we know that this is one of our products. We have to predict what the solubility of this compound is going to be. So we look back at our solubility rules, we see that the rule pertaining to sulfate are typically soluble unless combined with a few cations. Calcium is one where if it is combined with sulfate, the product or the compound is in the solid phase. So this will fall out of solution as a precipitate. And this is commonly abbreviated as PPT. So a precipitate is abbreviated as PPT. So with calcium sulfate, that is one of our products. Okay. Now, if we look at our next product, we want to take cation number 2 and cross it with anion number 1. So if we look at that, we have, let's see here, we have H. Okay. And notice how I'm not taking the subscript with from the original compound. You only want to take the element itself, unless it is a polyatomic ion. So here, you saw that I took the subscript with me when I went to do the crisscrossing, because this was a polyatomic ion. When we just have regular elements that are not in polyatomic ions, you do not want to take the subscripts with you when you go to predict your product. So here, it's not H2, it's actually just H. and this has a +1 charge. And then we see for anion number 1, this is a polyatomic ion, so I do need to take the subscripts with me. So this one has a -2 charge. So in order to balance this properly, we take our number and we cross again to become our new subscripts. So we would have H2CO3, and there would be one of them, and you know that this then goes on to be H2CO3. So this is our second product. However, if you recall from question number 2, this is carbonic acid, and carbonic acid does not exist in solution but actually decomposes to carbon dioxide gas and to H2O liquid. So carbonic acid decomposes. So we now have the remainder of our product. So we would have H2O liquid and we would have CO2 gas. So we have our chemical equation. The last thing that we need to do is balance it by mass. And if you check and see, we have everything balanced. So the subscripts for this reaction are all 1, and you can choose to write in the 1 in front of them for each compound, or you can choose to omit it because it is understood to be there. So double check your chemical equation, make sure everything is balanced, and we have now our balanced chemical equation. So in terms of our products, we already know what we have. We have calcium sulfate, we have liquid water, and we have carbon dioxide. Now, if we go on to predict what we're going to see in terms of experimental observations, well, you actually have a few that you might expect to see. One is that you know you're going to see the colorless CO2 gas evolve, just like what we saw for question number 2. In this case, we're also going to see a precipitate of calcium sulfate. So this one we should expect to see 2 different experimental observations.